Hey guys, welcome back. So the objective of this video is to continue on from the last video on the introduction of probability. So we're going to start this video with an example. So let's say we had a fair six-sided die and we only threw it once. So we let A be the event that the number on the top face is strictly less than 3. So by strictly less than 3, that basically means that the top face of our die must be 1 or 2. And so we must find the probability of event A from occurring. So that's P of A. So P of A basically means that we have to find the probability of the top face being either 1 or 2. So we first need to identify our set A. So set A is basically 1 or 2 because A is basically the number on the top face that is strictly less than 3, and we said that it was 1 or 2. So that's what I've done here, 1, 2. So afterwards, we're going to separate the set A into two smaller sets such that they have no common objects. So B intersection C must be emptied. So here, this is what I've done here. So I separated into two sets. So B carrying 1 and C carrying 2. And you see here that at the intersection of B and C is the empty set because the two sets have nothing in common. Because B carries 1 and C carries something different, which is 2. Okay, so A is equal to B union C, which is equal to 1, 2. Okay, so this means that A is composed of B and C, which carries 1, 2. So now we need to introduce a concept which we talked about in the last video, which is the addition rule. So P of A, which is what we're interested in, that's equal to P of B union C, okay, which is what we have here, and P of B union C is equal to the probability of B from occurring plus the probability of C from occurring, and this works because B and C are mutually exclusive. Okay, that's because the B of union C is empty. Okay, so because the intersection of B and C is the empty set, that means that B and C is mutually exclusive, and because B and C is mutually exclusive, that means that this equation can work. So now we just plug in numbers. So firstly, we need to find the probability of B. So B, we define that as the set of 1 carrying 1, the number 1. So the probability of 1 from occurring is basically 1 on 6. So set C, remember, was 2. Okay, so the probability of rolling a die and getting a 2 is again 1 on 6. So then we just sub that into our formula here. So P of A is equal to P of B plus P of C. And that means that it's equal to 1 on 6 plus 1 on 6, and that's equal to 1/3. So that means the probability of getting 1 or 2, or in other words, getting a number on top face that is strictly less than 3 is 1/3. So that's our probability, and that's our answer. Okay, so let's move on to the next concept. So in the previous video, we talked about events being mutually exclusive. So let's go on to a case where events are not mutually exclusive. Okay, so if events A and B are not mutually exclusive, then the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. And this is called the addition rule. So this is the equation that we use if events A and B are not mutually exclusive. Now, if events A and B are mutually exclusive, that means that this disappears. And the equation just becomes like this. Okay? So PA union B is equal to P of A plus P of B. And if it's not mutually exclusive, this is the formula for it. Okay? And this is called the addition rule. So I want to introduce another rule called the complementary rule. So in the previous videos, we talked about the complement of A. So the complement of the set A is basically the set of objects that are not in the set A. So the probability of the complement of A is equal to 1 minus the probability of A. So let's look at an example. So let's say, for example, again, you want to roll a die only once, and the amount of possibilities that you received was only 6, and that gave you 1, 2, 3, 4, 5, and 6. And so you're interested in finding the probability of rolling 2, 3, 4, 5, and 6. So one way we can do this is, we can again let A, our event, be equal to 2, 3, 4, 5, and 6. And this is what we're interested in. So the complement of A is basically 1. Okay, so basically the complement of A is again the set of objects that are not in A, and we know that 1 is not in A. Yeah. So we can therefore conclude that the probability of complement of A is basically equal to 1 on 6, because the probability of getting a 1 in a die is 1 on 6. So then we can use the rule up here, okay, the complement rule up here, and once we rearrange for P of A, we get this. So at the beginning we said that P of AC is equal to 1 on 6, so we solve it into here. So that will give us 1 minus 1 on 6, and that's equal to 5 on 6. So what that means is that the probability of the event A from occurring is 5 on 6. Or in other words, the probability of getting 2 or 3 or 4 or 5 or 6 in a die is basically 5 on 6.